Hi, everybody. Professor Monty here again. And today we're going to answer the question, what's a logarithm? And essentially, a logarithm is an exponent. And you may say, well, how can it be an exponent, or why don't I just write it as an exponent? Well, let's back up to something we understand a little bit better, a different question. If I asked you what the square root of 25 is, probably all of you would say, oh, that's 5, because we know what to do, we know how to do that. But remember, the question that's asking, it's saying, I'm looking for a number that when I square gives me 25. And we usually don't write that out, we just think that in our head, but we know that number has to be 5. And so the square root of 25 is equal to 5. That's my answer. Since 5 squared is 25. And so we know that. We say, okay, that's understandable. That's something that I know. That's something I've dealt with before. Well, a logarithm does something similar, except it's not looking for the base. It's looking for the exponent. So let me give you an example. Suppose I have log base 2 of 8, and I'm trying to solve that. Well, remember, I said a logarithm, this is a logarithm, is an exponent. It's saying 2 to what power is equal to 8. So that power that I'm looking for is what this logarithm is. This logarithm is that power. It's that exponent. Well, we know x has to be 3. So we can say, oh, log base 2 of 8 is equal to 3. That's my answer. That's what log base 2 of 8 equals. Since 2 to the 3rd power is equal to 8. So we found the exponent that answers this question. 2 to what power equals 8? 2 to what power equals 8? Oh, that's 3. So this logarithm is equal to 3. And again, you still may ask the question, well, why can't we just write 3? Why do we have to write this log base 2 of 8 stuff? Well, the reason is 2 to the 3rd is 8. That 3 is a nice whole number. That was easy to work with. Typically, the exponents aren't nice numbers. And in fact, they're not even rational numbers. They're irrational numbers. So we can get a calculator approximation, but the decimal goes on forever without repeating. Let me show you what I mean. Now suppose we have something such as log base 3 of 7. And I want to figure that out. Again, it's asking the question, 3 to what power is equal to 7? Well, I don't know what that is. I know 3 to the 1st is 3, 3 to the 2nd is 9. So since this is 7, it's somewhere between 3 and 9. So it's 1 point something, but it's an irrational number. Well, log base 3 of 7 is that number. That's what x is equal to. That's the exponent. And we can approximate that on a calculator. Some calculators you can actually put in the base. You can put it in log base 3 of 7. My calculator doesn't do that. My calculator, I have to use what's called the change of base formula. So I can rewrite this as either log of 7 divided by log of 3. So using base 10, because my calculator has a log base 10 button. Or I can do it as ln of 7 over ln of 3. So this time it's log base e of 7 over log base e of 3. Either one of these fractions, these ratios, is going to give you the same answer. So in my calculator, I'll just plug that in real quick. Remember, it's something between 1 and 2. So if I go log 7, close my parentheses, divided by log 3 equals, to 4 decimal places, I get this is approximately 1.7712. So that's a calculator approximation, and I can put 3 raised to the power of my calculator without rounding that off, the whole exponent in, and I'll get exactly 7. Or I can put in this rounded number and I'll get approximately 7. But that's why we would write it as log base 3 of 7, because I haven't rounded anything off. This is an exact answer. This is an approximate answer because I had to round things off. even if I went to the whole screen on my calculator, the calculator rounded it off to however many decimals it'll go. But that's what a logarithm is. It's the missing exponent that we're looking for. And a lot of times we don't see this until the end of the semester. If your teachers are anything like mine were, I would see logarithms at the end of the semester. And the instructor's probably behind, and they go real quickly through it. And I thought, oh, this can't be very important. But we use logarithms when we want to solve exponentials. So that's why we didn't need it before. We were just looking at polynomials or linear equations. But once I have an exponential equation, I'm looking for the exponent. I need logarithms. You can't solve those without logarithms unless you have a nice number like that 2 to the third is 8. But if it's an irrational number, you need logarithms. All right, hopefully that helps you out. Stick with these. They're not so bad once you get an understanding of what they are and how to work with them. And watch some of my other videos where I show you how to work with logarithms. And they're actually not so bad. We're just not familiar with them, so it takes a little while. All right, stick with it. Again, if you like my video, click like, click subscribe to my channel, and we'll talk more later.